Folks, welcome back. Hope you had a nice little break there. We got to spend this morning looking at strong assignments, what makes a good assignment in math class, and how to coach your folks if you're not seeing that. We previewed a little bit into this idea of strong instruction and how do we support teachers in, once they have some good tasks in place, how do we support them to grow as strong math teachers in that instruction piece? So that's where we'll spend our time today. We know our norms. You guys did an awesome job this morning participating. Thank you for the collaboration, having your cameras on, and being fully engaged and participating in the chat. We all learn more when we do that, so I appreciate that so much. Remember, we are recording, so you'll want to have yourself on mute, and we're going to continue to embrace that growth mindset as we push ourselves in thinking about what strong math instruction looks like. Another quick preview of our time together today. Most of our time will be spent watching instruction and working together to think about how to coach up the teachers in the videos. And then we will end our time kind of bringing it all together and look at an assignment with a video and really thinking about how would you coach to address both of those areas, because that's what you'll be doing when you go back to your campuses, right? Leading this instructional shift in how we approach teaching mathematics. So we have the same toolkit from this morning for resources. Elizabeth will drop it in the chat just in case you would like to pull it up again. But she will also be dropping those pieces along the way, the materials that you'll need along the way, so you can access those either way. And like I previewed before break, we are going to jump into our 6th grade math classroom. Oops, I see I'm not seeing the chat. Hold on. There we go. And observe this teacher in action. Now, when we're watching the teacher, here's what I'd like you to think about. We're going to get to spend about 12 minutes on this video, which is a long time to watch a video. But when you think about when you're in a classroom setting, that's about how long I would typically hang out in a classroom and take some observation notes. So with Elizabeth, you got to do some smaller, more chunked observations. So today we're going to do a little bit more of a longer experience. And picture this as like you're sitting in this class during a walkthrough. You'll notice that in this video, there's going to be some teacher commentary. It's brief, it's not, but she's going to zoom out and she's going to comment a little bit, but most of this video is about instruction. You'll get to watch her in action. So as you watch the video, jot down notes to yourself. Again, think of this as a walkthrough. What would you typically write down when you're in a walkthrough, right? You think about, what do you hear the teacher say? What do you hear the kids say? What is the teacher doing? What are the kids doing? So make yourself some notes. Don't worry about the rating tool yet, right? So we will use your notes to go back and look at the rating tool to rate her instruction. So right now we're just focusing on watching and jotting down some notes of teacher actions, student actions. Any questions before we start the video? Okay, fingers crossed I clicked that button. I think I did, but we'll see. All right, here we go. Maybe. There it is.
So today we're going to actually start learning Target 5 using our understandings of multiplication and division to divide fractions by fractions. So today the lesson was about having students tap into what they already know about multiplying and dividing whole numbers and multiplying fractions to begin to learn how to divide with fractions.
Oh, sorry.
Fractions.
Okay.
What was the big idea that we learned when we multiply fractions? What happens to the product when we multiply fractions?
I was going to say that it cuts in half most of the time.
So let's look back here up at this big idea. Multiplying by a fraction less than 1. Is 1/2 less than 1?
Yes.
Yeah. And tap into what they already know about multiplying and dividing whole numbers and multiplying fractions. What was the big idea that we learned when we multiply fractions? What happens to the product when we multiply fractions?
I was going to say that it cuts in half most of the time.
So let's look back here up at this big idea. Multiplying by a fraction less than 1. Is 1/2 less than 1? Yes. Yeah. And when we get 8 times a half, what do we get? 4. Is the product less than one of the factors? Yes. And then what happens when we take, which is kind of similar to what you were talking about, this halving idea. It's halves one of the factors. When we multiply a third times a fourth, what do we get? 12. Is the product less than both factors? Yes. So I want you to keep that in mind today as we start dividing fractions. And instead of using the language of factor and product, we're going to be looking at the
Sorry, y'all. I can't click anything. Hold on just a minute.
language of dividend, divisor, and quotient. So today I want you to be thinking, what happens to the quotient when we divide by fractions? When you look at the standards and how they're written, the division standard is actually quite complex. It's not just a simple students learn how to use the algorithm to divide fractions, which is what we might see in some of the former state standards that are out there. But if you actually look at it and think about it, students need to understand and interpret the quotient very clearly, that it is larger than the dividend and the divisor. I want you to silently think to yourself and solve to yourself this problem. And even if you're not sure, that's okay, because that's what we're going to do today. We're going to figure out how to solve problems like this. All right, go ahead and turn to your partner. What do you think the answer is to 3 divided by 1/2?
1.5. It's 1.5 because a half of 3, a half of 2 equals a half, and then a half, well, no. A half of 2 is 1, and a half of 1 is 1/2.
Yeah, so if you add those two, you get 1.5, which is half of 3.
Yeah.
What were some of the answers that we had? What were some of the answers? Alondra?
1.5.
So one of our possible solutions is 1 1/2. Marlene? 6. Any others out there? Jesus?
I got 1 1/2.
Great. That one's already up here. Any others? All right, so we have 2 answers. These answers are quite different from one another. So now what we're going to do is we're going to try to make sense of this. Is there somebody who'd be willing to share their thinking about how they got 1 1/2 or how they got 6?
I divided 3 divided by 1/2, and I knew that half of 3 was 1 whole and 1/2.
Okay, so you thought of 1/2 of 3 is 1 1/2?
Yeah.
Okay, and let's hear from another.
I don't know what the answer is, but I don't think it's 1 1/2 because 3 times 1/2 equals 1 1/2, and we're dividing.
Interesting. So let me get a different color here. So you are saying that 3 times 1/2 equals 1 1/2. Okay. Turn and talk to your partner. What do you think about this statement? Is this true?
We're dividing and not multiplying.
3 times 1/2 is true because 1/2 3 times is 1/2 plus 1/2 equals 1 plus 1/2 equals 1 1/2.
I did the division algorithm for the problem, and I ended up getting 2. So I'm actually agreeing with Annabelle that it might not be 1 1/2.
Okay, so you're not sure this is the correct solution, but you're also not sure what it might be. And it sounds like you've learned some sort of a procedure for dividing fractions,
Yes,
but you're not sure. You're confident with it or not sure?
I'm confident.
You're confident. Okay, so you think the answer is 2? Okay.
I remember that division means groups of. So they're trying to find how many halves are in 3, and that's 6.
So I'm looking 3 into groups of 1/2, okay? Or I could say 3 into 1/2 parts. And you're saying that's 6.
Yeah, because 1 there's 2 halves. 2 halves. So in 3 there's 6.
Because the people that are saying it would be 1 1/2, that would be multiplication, but we're talking about division.
So you're saying that a multiplication problem and a division problem can't have the same answer?
Because Well, sometimes they can, but like in this case, because it's saying that 3 times 1/2 does equal 1 1/2, but I don't think that 3 divided by 1/2 equals 1 1/2.
The best part of the lesson today was listening to the students think about making sense of this problem, 3 divided by 1/2, and being so convinced that it was 1 1/2, which was incorrect, and trying so hard to come up with evidence for why they felt so strongly that 1 1/2 was the solution. There was the great moment when a few kids said, well, I know it's not 1 1/2, because if you multiply 1 1/2 times 1/2, you don't get 3, and multiplication is a check of division. So I loved hearing that. What I want to do right now is talk about what mathematicians do when they are trying to make sense of a problem. We're trying to make sense of 3 divided by 1/2, and we have 2 ideas. Most of us are saying 1 1/2. Some of us are saying it's not 1 1/2, but I'm not sure what it is. And then we've got some of you that are saying it's 6. So, is this our problem? Yeah. All right. So I'm going to take out our fraction kit pieces. So we're going to try to make sense of this problem by, let's model. So if we were to do 3 into groups of 1 1/2, by looking at this model, I want you to look at this model and talk to your partner. 3 into groups of 1 1/2. How does this model help support your idea or change your idea?
The model that you put supports my answer because 6 is also the answer, but it's because it's like how many B's go into A, and how many.
Hang on. How many B's go into A? What division statement is that? Number 2. How many B's go into A? Okay, so keep talking.
So I just put like how many halves go into 3, and I got 6.
I would like to agree with my answer, which is 1 1/2, because if you we're dividing 3 into like its half, so it would be 1 1/2 if you cut that in half.
Okay, so is this problem 3 divided by 2? You're saying this is what we're doing?
Sort of.
Sort of? So you're saying that these 2 would have the same answer? Yesterday, we agreed that all 10 of these statements were true. That you could model a division statement by thinking of the dividend as A, the divisor as B, and you could ask yourself how many B's, how many divisors go into A. So if we use what Clinton said, this would be our B, and this would be our A. How many B's go into A? Does this make sense? 1, 2, 3, 4, 5, 6? Yes. Makes sense. So that whole moment of dissonance and disequilibrium around 3 divided by 1/2, which took 10, 15 minutes, was so great in hearing so many kids share their thinking and try to prove their idea and their answer with evidence. So I was thinking about what's long that we could divide? And then I was thinking, well, candy, it's Halloween's coming up. So I was envisioning licorice, although would you believe it, licorice is the only candy that I actually don't like. But it works for this model. Imagine we have a long rope of licorice. It's 2 feet long. And I want to divide, Ismail and Brian, I want to divide this rope of licorice into 1/6 of a foot pieces. So my question for you is, how many pieces of licorice will I have if I divide it into 1/6 pieces? And to do this, I'm going to give you a fraction kit for you and your partner to see if you can make sense of this problem with a model. And what I love about the Common Core in math, particularly the mathematical practices And so for me, I feel like they have unleashed this new excitement around teaching when I'm really starting to think about not just students mastering skills, but mastering ways of thinking and thinking about how do I measure kids' ability to use models and make sense and critique the reasoning of others. So I feel like for me, it's expanded all the possibilities of what I can do with my lesson planning, and just it's challenging. So I checked in with most all of the tables except for this table, so I'm gonna actually go to this table. How many pieces of licorice did you guys decide I would have? Angie?
12.
12. And how did you figure that out?
Because like there's 6 on this side, and then we put 3 on 1/3 instead of the 6, and then it also equals 6, and 6 plus 6 equals 12.
Ah, okay. I want you to now go back to our problem, and I want you to put 3 pieces of licorice. Now your rope is 3 feet long. So go ahead and put 3 blues in the center of your table so everybody can see. And this time I want you to divide it into 1/2 pieces. 1/2 pieces.
It has to be 6 because it has 2 pieces on each one. If you do 2 times 3, that's going to give you 6.
That's gonna be 6 because like
4, 6.
because two 1/2 equals 1 whole. So how many halves go into 3? 6 of them. So 6 is gonna be the answer.
4, 6.
So are we convinced now that 3 divided by 1/2 is actually 6?
Yes.
All right, so here's what we're gonna do now. Now I'm gonna mix it up one more time. We're gonna do one more problem together, and then I'm gonna give you a chance to practice. And the problem that I want you to do now is 1/2 divided by, imagine I had 1/2 foot of licorice. I have 1/2 foot of licorice, and I want you to take 1/2 and I want you to divide it by 1/4. How many pieces? I think what we'll do tomorrow is continue to finish working with the problems that we started and stopping and pausing for questions. What I'd like to do before we close is just turn your attention back here to our mathematical practices, and I want you to just call out, did we work on making sense today?
Yes.
Yeah. Did we think and reason with a situation?
Yes.
Did anybody get hungry thinking about licorice?
Yes.
Did we use evidence to support our ideas?
Yes.
Yeah, that was really great. Did you guys notice, Brian and Ismail, did you notice how Jordan gave an example to support his idea? He was using evidence. And then also, did we critique each other?
Yes.
Yeah, we had 2 different answers for 3 divided by 1/2. Did we model?
Yes.
Did we use appropriate strategies and tools from our toolbox?
Yes.
Yep, our division statements. And were we precise with our notation and communication?
Yes.
We had to correct each other when we were using vocabulary, factor is product, dividend, divisor, quotient for division. And then last but not least, were we looking for patterns and making connections?
Yes.
Yes, we were thinking about our work with multiplying and how does that relate to division?
Okay, I'm gonna give you a minute to kind of wrap up any last minute thoughts that you had that you wanna jot down on your notes. And let's see what we're gonna do with this here. So we are not going to practice rating culture of learning, but I did just wanna share that this classroom had a strong positive culture, which we know is necessary for math instruction, and evidence of that, we saw that kids felt safe in sharing their answers. They felt okay questioning each other about their answers and defending themselves with arguments. All of that shows that the teacher has built relationships and put things in place to help kids feel like they can take risks in her class. So we're not going to actually rate on that today because we're going to focus more on the content. And I'm actually going to have Elizabeth drop into the chat this modified walkthrough form that's just focused on this lesson. I took the culture of learning off and I added the standards that the standard that the teacher said that this was addressing. And I also included the 5th grade standard on here. So remember, this was a 6th grade class. So I gave you both the 5th grade standard and the 6th grade standard that are aligned to this lesson. So your task right now is you're going to take this walkthrough tool. And I think Elizabeth, the link to that rigor cheat sheet is in there too. She's going to drop that just as you're looking at the high quality mathematical content piece. You can look at that rigor cheat sheet to help you with that piece. But we are going to go to breakout rooms, and you'll have 8 minutes to work together to rate this teacher's instruction. So you can use all the tools that you have available to you in that rating toolkit with the rigor cheat sheet, and then this specific walkthrough form. And let's see what you're thinking on where this teacher falls with her instruction. Before we go to breakout rooms, are there any questions? Okay, well, we'll see you back in a minute and be ready to share out what your group talked about. You all. And we are recording again. Here we go. Okay, so let's talk about it. What did you guys think? We'll start with the high quality mathematical content. So when you looked at the standards that I gave you that correlate to the lesson, like how did you all rate this? What did you think, and what evidence did you collect? So let's do, let's have you go ahead and drop in the chat. Did you give this a yes or a not yet for this lesson? What'd your group come up with? Oops, I've lost my chat.
Got lots of yeses for stuff. We
Thank
can
you.
narrate those for you while you're looking for your chat. Ooh, but someone has a yes, but no. So I'm really curious about that.
Okay, that's interesting. And yeah, I'll have to find what happened to my chat, but thank you, Elizabeth, for helping me out with that. So yes, but is an interesting one, and we'll kind of come back to that. Here's some things that, as I was collecting evidence on this lesson, that I thought about. So when you looked at the focus, we ask ourselves, does it focus on the depth of the grade level, course, or grade? I'm curious, the person who said yes, but, was that the area that you were wondering about? Was that where the but came from? Was it from the focus, coherence, or rigor piece? Someone mind unmuting and sharing your yes, but?
The reason why it was yes, but no, there was great rigor. The only thing was it didn't really address the 6th grade standard. If I was comparing it to the 5th grade standard, absolutely. So that's the reason why, yes, what we've seen was amazing. It is correct in the instructional shift that we're going for, but at the same time, it didn't actually address the specific standard.
Yeah, so when we get, that's the interesting thing here. When we get towards the end of her lesson, we do see that she's introducing the fraction divided by a fraction in a very conceptual, concrete way, which is what the standard calls for, right? And for them to be able to understand why that works. So I hear what you're saying, because she did spend a lot of time on the 5th grade standard. Why do you think she might have done that? Anybody can unmute and share. What do you think her strategy or her purpose was there?
Probably to scaffold from the year before's learning.
Yeah, and based on the answers that we heard the kids give, do you feel like it was time well spent? Yeah, I'm seeing some head nods. Yeah, like, so I wonder if when she was planning, if her thought was she was going to do a quick intro, right? Of, hey guys, like, remember divide, and then quickly realized, ooh, like, they're not sure on this one. In fact, most of my kids have a huge misconception here, and did a quick pivot and spent a little more time there. That's the power of these debrief conversations with teachers later, right? Is you get to ask those questions. So tell me why did you spend this much time here? So yes, great catch. Overall, this would be a yes. right? And if I was to circle it, because it's on this like bar of yes, I would pull it maybe closer to the middle of yes, because there was a lot of time spent on building up that knowledge from previous grade levels. And just FYI, Elizabeth, I still can't see my chat. So if anybody says anything, let me know. So yeah, she also did a great job in the coherence of connecting what they should have learned in 5th grade to what they will learn now, which is essential to this standard because dividing fractions can be a very abstract and confusing thing for kids. So she did a great job of doing that. And the rigor was on point with the whole, it was very conceptual. And that's that 6th grade standard requires that kids understand what's happening when they are dividing fractions. So this lesson was super different than how I was taught to divide fractions. So when I was in school, this might sound familiar to you all, ours is not to reason why, just invert and multiply. Like I can sing that little song in my head. That is how I was taught to divide fractions. Now, could I do it? Yep, I could do it all day long. I still remember the rhyme, right? Do I have a picture in my mind of what's happening when I divide fractions? Nope, like I don't. So this lesson was a great visual to help us see like what could it look like to teach for understanding, to show kids what it actually means when we are dividing by a fraction. And this teacher did a great job of that. So when you're in math classrooms, and again, this goes back to the, like, I never taught calculus, so I'm not really sure what it looks like to help kids understand concepts at that level. I go back to, what I'm listening for and what I'm looking for? Am I hearing like something for kids to memorize to help them get to an answer? Or am I seeing that there is something in place to help kids understand what's happening? So even if you're not super comfortable with the content, those are things that you can think about when you are observing in classrooms. All right, so the next area you were asked to consider was the high quality instructional practices. So on this one, let's do that same thing, even though I can't find my chat, but go ahead and type in, what did your group decide? Not yet, somewhat, mostly, or yes. Be ready to share some evidence. There's my chat. I found it. Cool. Okay. I'm seeing lots of yeses on this one. All right, who would like to unmute and share some evidence that your group talked about in this area? Why'd you give her a yes?
I thought she did a good job of strengthening students' understanding by sharing, you know, different students and the way they were making representations. And that's bullet point number 3 in this one.
Yeah, she did do a great job of that. She was using that student work and their modeling to help them figure out that their initial response wasn't correct, right? She'd have to tell them, nope, that's wrong. They figured it out on their own. Great. What else did you guys notice?
One thing that we haven't talked about that I thought she did a good job of was using strong academic language. So she was using terms like dividend, quotient, multiplier, divisor, factor, which I thought added to it. And then I like that she took the time, rather than getting to the how, she got to the why and trying to develop the conceptualization of it. Yeah. Without telling them directly.
Yeah, she didn't really directly teach anything, if you think about it, right? Like she presented them with the problem. They tried to reason through it. She gave them tools to consider and then let them come to conclusions on their own. So yes, I would agree with you all's evidence and assessment that this would rate as a yes for high quality instructional practices. So let's take a look at the next one here of student ownership. So go ahead and type in the chat, what'd your group think? Where'd you rate her on student ownership? Seeing a lot of yeses here. Anyone like to unmute and share some evidence that you collected to support your yes rating?
We talked about the norms that she had obviously said in her classroom with just the student vocabulary, like right before they would answer a question, they would say, I agree with Isabel, or I agree with.
Oops, we lost you. Okay, I don't know, I'm not sure what happened. We lost you, but yes, I agree. She obviously had set up her classroom and that culture and those norms of how to engage in conversation and how to respectfully disagree and agree with your peers and use evidence to support that. Yep, what else?
I like the way she got the kids to explain how they're thinking or what they're thinking or how they're reasoning it through it with each other. And then they shared and they fed off each other and learned from one another.
Yeah, and that kind of stuff doesn't happen by accident, right? Like she planned for those moments, and there's evidence that she thought through the types of experiences that she wants kids to have to foster that conversation. Absolutely. Anything else?
One thing I think it takes, as we saw, it takes a lot of time to do it that way. And so it's a different way of how you spend your time in the classroom. So if you're teaching procedurally and you're just following steps and flipping your reciprocal and multiplying by that's an easy way to get to the meat of it quickly without the conceptualization. But then the time or the rest of the time spent in the classroom is a lot of time practicing those types of problems repetitively. So it's just kind of a switch about where you spend your time instructionally in the classroom as well.
Absolutely. And it's interesting because when you do teach procedurally and teach those steps, you're right, like that front part goes a lot quicker. You can get to the practice part of it. And kids might be successful on day one of practicing. They come back and maybe they forget, right? Because they just memorized a procedure and they didn't really get what they were doing. So you might spend more time on the back end because you keep having kids who struggle to remember the steps to the procedure versus these kids have an experience that they can anchor their understanding in of like, oh yeah, I remember when we did that with the strips and we saw this. So absolutely, it is looking at how we choose to spend our time, the time that we have with our kids. What are we choosing to do with it? Yep. Anything else? Yeah, I agreed with y'all. It was a strong example of a classroom that has strong student ownership. We talked earlier about how really she didn't do a lot of direct teach. It was really using what kids were saying to spring conversation and to trigger investigation and discovery by the kids. And then she kind of ties it up at the end of like, well, yeah, you're right. That is what this is showing us. And this is how you do this with fraction divided by fraction. How do you transfer that? So very strong example. And it's, of course, there's areas of improvement. There's always areas of improvement. But this teacher did do a great job of embracing the intent of the standards and the shifts that we're trying to get at with in math instruction and the standards for mathematical practices. The students were the ones who were doing most of the talking in her class, and therefore they were the ones who were doing most of the thinking. Again, this is very different from math classrooms that I experienced growing up, and I would venture to guess that this might be different than the way your math teachers on your campus were taught. And so this is a big shift in thinking about how we approach mathematics instruction. So keeping that in mind, we're going to spend a few minutes in reflection, thinking about what do you see at your campus right now? when you've been in classrooms, how would you answer this question? Do students at my school have consistent access to rigorous instruction in math classrooms? So think about it. Think about what evidence you have to support your claim. And then what are you going to do about it? Like if you aren't seeing it like you would like to, what are some things that you could do? Thinking about how would you use maybe some structures you have in place already, some PLC time? How might you use non-evaluative walkthroughs to coach teachers? Do you have support staff on campus that can assist you with that? This is really your time to reflect and then brainstorm. How will you bring this back to your campus and make changes that you want to see in classroom instruction? So I'm going to give you about 5 or 6 minutes to reflect. If you'd like to turn off your camera, you're welcome to do so, and then we'll check back in. about 30 more seconds to kind of wrap up your thoughts and come back on camera when you're ready. All right, so we're going to come on back. Hopefully you had some time to reflect on when you're walking classrooms, do you see kids doing most of the talking and thinking? Or are teachers focused on the mathematics versus the procedures, and kind of thinking about what would you like to do about that? And we'll talk some more about some next steps towards the end of our training. So what we'll do now is we're going to shift, we'll move into our case study. So during this case study, you'll have the opportunity to look at a teacher's assignment and her instruction and kind of do a more holistic rating, combining the two skills that we've practiced today, practicing with the assignment rating tool and practicing with the instruction rating tool. So now when Elizabeth shared this with you on Tuesday for the science portion, this structure that you see on the screen is a great structure to support teachers. By starting with that assignment, you're able to give feedback and make an impact on the classroom instruction before the lesson is even taught, right? Get in there, give some feedback on that. But we also recognize that this isn't always how the sequence works, right? Many times you're just popping into classrooms, collecting assignments that are given in the moment, and you're kind of doing more of an autopsy on the assignment, right? It's already been given, you're kind of looking at, you know, what it was. And that can be, there's value in that too. So the scenario that we're going to practice today is actually that second one. So we're going to treat this as you're doing instructional walks today. You pop into this teacher's classroom, you grab the assignment that you see on the desk, and you're going to use that to kind of evaluate what's going on in the classroom. So for our case study, we are going to use Ms. Dennis's class. You'll have an opportunity to look at Ms. Dennis's lesson plan as well as the assignment and her exemplar, like what the teacher filled out of what the correct answers are. Then you'll have a chance to watch several minutes of instruction. And after that, you'll have the opportunity to use the instructional tool to rate the assignment and the walkthrough tool to rate instruction. And we'll practice what kind of feedback might you give to the teacher. So before we pop in and observe Ms. Dennis, I want to give you some context. This is a fourth grade classroom. This is the lesson plan and the assignment, which you will have copies of. Elizabeth's going to drop that in the chat for you, so you have that artifact to look at. So go ahead and click on that link and take a look. Now remember, it is more impactful to look at the assignment ahead of time, but we're going to go with, this is how sometimes this works, right? You walk into a classroom and pick up the assignment. So take 3 minutes, read her lesson plan, check out her exemplar assignment, and then we will be ready to observe her class. All right, remember, you don't have to rate right now. Just kind of looking it over. You're sitting in the classroom, sitting in the back there, checking out the assignment. And now we're going to get ready to observe her lesson. While you're observing, again, jot down some notes, things that you notice. What are kids doing? What are the teacher doing? What are they saying? Don't worry about the tool yet. We'll rate that later. All right, here we go.
What exactly does a fraction show, Amaya? What does a fraction show?
A fraction shows parts.
A fraction shows parts. Parts of a what, class? Parts of a whole. Now, is this a topic that we're just learning in our book and we're never going to use it again? No. How do we use fractions in our everyday lives?
When you're like a person that cooks.
How would a person who cooks need fractions?
Like measurements to cook, like you gotta make milk.
Okay.
Put it in cups so you can put it in a pot so you can make the cake.
Okay, good. Like in baking a cake. And what tool would a chef use to determine their fractions?
A measuring cup.
A measuring cup. Good. Another instance that we may see fractions every day is when we're working with tools. What are some tools in our classroom that we've used during math class that actually show fractions? Jalen?
The fraction strips.
The fraction strips. Good. That's an exact example. Nadia, what is another example where we may use fractions in our classroom?
When we're using rulers.
When we use a ruler. With math, I think it's very important to connect their skills to real life experiences and everyday real life activities that they may encounter, so that they know that this isn't something that they're just learning because it's in our book. It's a lifelong skill. All right, so the first way that we're going to talk about comparing fractions is by using visual models. And the visual model that we're going to use today, which is something new, is our big inch. And it's exactly what its name says it is. It's a big inch. This is like taking 2 little bitty inches from a ruler and blowing it up. And we're going to use this to compare fractions. I'm not going to tell you anything about what's inside this bag. I want you to open it up, explore, and talk with your partner about what each piece might represent.
Those are the 4s. How many? 1, 2, 3. How many is that? This, how many you got? 1, 2, 3, 4, 5, 6, 7. Then more. And this 8. It's 8. So these 8s. 1, 2, 7. These are 8. 3. This one is 8, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. And this one and the yellows are 16. You want to see if it makes 2 if we put the 2 over it? Let's see if it makes 2. Hold up, that's 2. Yes, it makes 2.
Okay, let's look at the big inch. We're going to use this instrument to compare fractions that don't have the same denominator, okay? Take out for me 1 green bar and put it in the hole. Put it at the very end where 0 would be. Very good. Only 1. Only half. Okay? Now, so what fraction does this green bar represent again, class? 1/2. Okay? I want us to compare 1/2 to 2/8. Which color did you all tell me represented the 8s? Red. Take 2 of the 8s, and you're going to put the 2 8s on the stage behind the half. Only 2. How many 8s do you all have? Only 2. And they should be standing up, you guys. Like this, just like mine. 2 8s. Now, how does 1/2 compare to just 2 8s?
1/2 is greater than 2 8s.
1/2 is greater than 2. How do you know that, Kalia?
Because the 2 red bars are lesser than the green bars.
They're how do you know they're less? What are you looking at? You're looking at its what?
Length.
So we said that 1/2 is greater than 2 8. So which fraction will the alligator class be eating? 1/2. The 1/2. So 1/2 is greater than 2 8s. Okay? So I'm going to give you some fractions, and you're going to use your visual model to compare. Are we ready?
Yes, ma'am.
All right. 3/4 compared to 7 8s. 3/4 compared to 7 8s. How does 3/4 compare to 7 8s? So you have your 3/4.
I got this.
The way in which I've changed my teaching since Common Core was introduced is having the children to explain their thinking more. Especially in math, it's no longer just getting to that final answer, but it's taking the time to explain their steps and their actual thinking. How does 1/2 compare to 12/16?
It is less than.
How do you know?
Because there is more 12s. I mean, there's more 16ths than. There's more yellow ones than green.
What are you looking at? Are you looking at the number or?
The number.
The number or the length?
I said the number.
The number. So because we have this 12, you're telling me just because this has 12, it is longer? Remember, we talked about fractions. Fractions can be tricky because sometimes do we actually have to look at the size of the number? No. When we've done equivalent fractions in the past, we've seen instances where the fraction with the larger number may actually show a smaller amount. So when we compare using a visual model, are we looking at the numbers? No, because this is a ruler. What does a ruler measure? The length. So when you compare, you're actually comparing it not by the number, Sanaya, but you're comparing it by the what? The length. And we can see that the length of 12/16 is longer than the length of the what? 1/2. Of the 1/2. Of course, I started with the visual big inch, which was more concrete. They could visually see that it was longer. I went next to using the least common multiple because they had the background knowledge for completing that method. And Terius, if I had 1/3 compared to, let's say, 2 8s, what could I do to actually compare them? Their denominators are not the same. What could I find?
Find the lowest common multiple.
Let's take the example 6 8s and 4/5. How does 6 8s compare to 4/5? Can we compare them as they are? No, we must make them have common denominators. In order to do that, we have to first find a multiple that they both share. Prior to today's lesson, the students learned to form equivalent fractions. They learned to form equivalent fractions by both multiplying the numerator and the denominator by any number, and also by dividing the numerator and the denominator by a common factor. We're going to compare our 8s to our multiples of 8 and our multiples of 5. Okay, now, what are your multiples of 8?
8, 16, 24, 32, 40, 48, 50.
All right, good. Very good. Typically, we would go through and list the multiples of 5, But can we tell which multiple is going to be the least common multiple without listing it? Sanaya, which multiple would that be? 40. How do you know that 40 will be the least common multiple of 8 and a 5 without writing out your multiples? How do you know?
All the multiples of 5 are going to end in a 0 or a 5.
And what least common multiple did we find again? 40. Now that means that we can go back to this prior knowledge we already have. We can, if we change 6/8 to a fraction with 40 in the denominator and 4/5 to a fraction with 40 in the denominator, we can compare. Can we do that? Yes. Yes. Let me see you do that on your paper.
That's where I stopped it. All right. So here's your task. Finish up any notes that you have jotted down about Miss Dennis's classroom.
What exactly?
Nope. Here we go. So what you're going to do is you're going to go back into breakout rooms. Before that, Elizabeth's going to drop a link in the chat to the toolkit. They'll have all the resources you need to identify glows and grows for this teacher's assignment and instruction. So you already have the case study artifact. In that artifact, you have the standard that the teacher was addressing, at least the number of it. So you might have to use your tools to figure out what that standard is, what it says. And your task is to think about this holistically. So what strengths would you identify after reviewing the assignment and the instruction? What would you name as high leverage areas for growth? And then thinking about like maybe what would be some next steps that you would take with this teacher in your debrief coaching conversation. So we'll have about 12 minutes in breakout groups to do this. Don't get too hung up on rating each piece. Again, we're using those tools and starting to internalize that process and think about how would you use that to give feedback to this teacher. Before we go, what questions do you have? All right. So be ready to talk glows and grows when we come back.
For those of you who are watching the video, please press pause now, take 12 minutes and follow the same instructions that the breakout groups are following. Thank you so much.
So let's chat. What are some of the glows that you all talked about for Miss Dennis, for her class, for her instruction, her assignment? What were some of the positives that you saw? Go ahead and unmute and share. You can type in the chat too if you'd rather.
I saw that seems like in the chat, visuals and manipulatives and devices like that were strongly used. I also thought that she was very strong in the area of questioning and building a sense of relevance. You know, so many times when we talk about fractions, we talk about pizza or something which is easy to understand. But I really liked that a kid brought up the idea of a chef using measuring cups. And I liked how she also talked about the tools that different industries use for measuring fractions.
Yeah, absolutely. What else?
In our group, Stephen brought up that where she brought the bags out, it shows it's a model of student ownership. Like the students had to really engage in the process more than just, you know, respond, repeat, that sort of thing.
Yep, I noticed that too. Anything else? I think I noticed similar things to y'all. Here's some things that I noticed. Yep, she's using manipulatives, which was appropriate for the standard. She also connected it to prior learning when she talked about how they had used LCMs before. So this was something that she could connect to, and she explicitly made that connection, help kids make that connection. And then the kids were engaged, right? They were doing what she asked, and they were volunteering responses. So let's talk a little bit about grows. And again, this can be for what you saw in instruction. This can be on the assignment. What were some things that you all talked about that could be growth areas for this teacher? And you can unmute, or you're welcome to type it in the chat. Did y'all get to grows?
One thing we talked about was allowing her students to articulate their learning a little bit more. She was a little quick to kind of jump into explanations or affirm what they were saying, instead of kind of letting them process that out and really demonstrate their conceptualization understanding through words. So I think that would probably be a high impact, high growth area that if I was going to focus on one, that would be the one I'd focus on.
All right, nice. And I see Jack said something similar, allow students to be more involved. Anything else that you all pulled out that you want to focus on?
Gina brought up the alligator. That's like a thing that I think a lot of high school people don't really love, that especially when there's no distinct explanation of what it actually means or how it reads. Like, it's very common, well, the alligator eats this one.
Yeah.
It's not, if you're going to vertically align, that's something that's real scary when you start to get to linear equations or linear inequalities, I should say. It becomes a problem. So that popped up in there. She brought it up. I completely agree. Maybe that's a high school problem.
I tried really hard to like not show any like facial grimaces when she said that. I was like, oh, because that's my reaction too. So yeah, so there could be some discussion around that. Yep. Anything else? So again, I think I pulled out similar things. When I was thinking about the grows, this was heavily teacher directed. She did ask questions, right? But the kids didn't have an opportunity to really think, especially when they got to the least common multiple piece. When they got there, it turned into this very procedural driven focus, right? There wasn't a lot of opportunity for kids to bridge the conceptual understanding of the size of the fractions that they used for the big inch part to this new method that she's showing them with the least common multiple. That is a procedure that you can use to compare fractions, but there are other ways to compare fractions. Did anybody get to dive into the standard, and did you notice any other ways that kids were supposed to be thinking about fraction comparisons that was named in the standard?
They also needed to compare it to standard fractions, which that was really just procedural there. The way the lesson was done was procedural, but it was not that. And also kind of identifying when you have to compare numerators versus denominators, and there isn't a lot of conversation about that in the video. I mean, it's a clip, so who knows?
Right, and to be fair, like that's why debrief conversations are so important, because you're not usually in there for a whole lesson. So those are good follow-up questions to ask, because in the standard it talks about this idea of benchmark fractions, like comparing things to half. And when you look at the assignment, many of those fractions that the kids were having to compare, if you understand the size of fractions in relation to half or a whole, you didn't have to do anything, because you would know, oh, well, of course, 7/8 is larger than 1/3 because it's closer to 1. So that's the type of thinking that kids should be developing about fractions. And this lesson didn't allow them to do that. It jumped straight to a procedure that they do need to know how to do, However, maybe not the one I would start with when I'm building their conceptual understanding of fractions and how to compare those sizes. So yeah, I agree that the standard called for some more conceptual understanding that we didn't see there. Did you all get to dive into or kind of talk about next steps at all on how you might coach this teacher? There wasn't a whole lot of time, right? So here's some things that I thought about, and I'll show you some of the tools or the resources on where I found these things. So much like what we talked about, one thing we noticed was that she did do a lot of the thinking for the kids, and there's a lot of teacher talk in that video. And so I'm going to show you, actually, I'll advance one more slide. On your toolkit that you have access to, there's resources for coaching teachers to improve instruction. And so if you're looking for, if you notice on your campus, I've got a lot of teachers who are doing all the talking. There's some tools here for that. So this explicit planning versus explicit teaching is a great tool to use with teachers in PLCs and training time to think about how do you leverage questioning to get kids to do the thinking so that you're not doing all the talking. The 5 practices for orchestrating productive math discussion is another one that's a wonderful tool if your campus is looking for a book study to do, or you just want a quick guide with some high school examples in it. There's some resources here for you on that. So these tools could be helpful in thinking about how would I coach a teacher who maybe is either proceduralizing things too much or is doing more of the talking than you'd like to hear in the classrooms. So those tools could be helpful when you're thinking about next steps. They'll address moving away from, like, when you hear things like, let me tell you how to do this, or these are the steps on how you solve this problem. These tools will help you move teachers to be more, where you hear more things like, let me help you learn how to think through this, right? Which is a different statement than let me tell you how to do this. All right, so we have made it through our session today, and you have been able to practice with the tools. You have practiced implementing them in different ways, in different situations. So our last bit of reflection, and we're going to do it very quickly, jot yourself some notes on what professional development opportunities do your teachers need to grow in these areas. So I'll be quiet for a couple minutes and let you think, and we'll end with our attendance survey. All right, and as you're finishing up your thoughts, other things to consider in this area are things like, what structures do you have in place? Do you have PLC time? Do you have collaboration time? Do you have planning time for teachers? What opportunities do you have as leaders to get in and do non-evaluative walkthroughs where you can really truly have these coaching cycles? So those are things to continue to consider as we leave you for today. Our last thing to wrap us up is our attendance survey. On this survey, I wanted just to highlight for you, there's going to be a question on here that's actually for you, for instructional leaders, that if you want to be a part of our educator working group, there's just a place for you to say yes or no, if you're interested in that. And that's really going to be an opportunity for you to give feedback on how STEM.LD is going at your school and help us strategize and plan on how to make this experience beneficial for everyone. All right, so we'll let you go ahead and take that survey. I'll stick around for a few minutes if anybody has any questions or wants to chat. And thank you all for your participation and your collaboration today.